What does the double slit experiment reveal about reality? Fire particles one at a time through two slits, and they interfere with themselves like waves. But only when nobody's watching. Hey everyone, and welcome back to the channel where we tackle some of the weirdest and most mind-bending ideas in science today. Because honestly, reality is a lot stranger than we often realize. Have you ever found yourself staring at a wave in the ocean, marveling at how it can seem to flow around a rock, bending and curving in a way that defies simple logic, and wondered about the fundamental nature of what we perceive to be true? Well, today we are diving headfirst into one of the most perplexing experiments in the history of physics. An experiment that challenged our most basic assumptions about how the universe works, an experiment that involves tiny particles behaving in ways that seem utterly impossible. See, it's the double slit experiment. At its core, the double slit experiment began with a simple setup. Scientists aim beams of electrons, incredibly tiny particles that make up everything around us, at a barrier with two narrow slits, almost like a doorway, allowing them to pass through. The surprising thing is that when they observed the electrons as they went through, expecting them to pass through one slit or the other, creating two distinct lines of hits on a screen behind the barrier, something completely unexpected occurred. Instead of two lines, the electrons created an interference pattern, a series of bands of high and low density, just like the ripples you see when you throw a stone into a pond, demonstrating wave-like behavior that's characteristic of water waves. This was immediately baffling because electrons, as far as we understood at the time, were considered to be particles, discrete units of matter like tiny bullets, and bullets don't typically create interference patterns. So something was fundamentally amiss here. Scientists then decided to observe which slit each electron was passing through, thinking that simply knowing where the electron was going would force it to behave like a particle, and we would see the expected two lines of hits on the screen. However, the moment they tried to watch to observe the electron's path, the interference pattern vanished completely and the electrons resumed behaving like particles, creating two distinct lines, as if our observation was somehow influencing their behavior. This is where things get truly bizarre because it suggests that the act of observing a quantum system, like an electron, fundamentally changes its behavior, and that's a concept that deeply troubled even the greatest minds in physics. Imagine trying to determine the color of a flower. If you simply look at it, you're still seeing a flower, but if you try to measure its wavelength of light, you might inadvertently alter its color just a tiny bit. The double slit experiment seems to suggest that quantum particles like electrons don't have definite properties until they are measured, and that the act of measurement forces them to choose a state, collapsing the wave function that describes their potential existence. Think about a coin spinning in the air before it lands, it's neither heads nor tails, but a combination of both possibilities existing simultaneously until it's observed and forced to take on a definite state. Scientists believe that before observation, an electron exists in a superposition of states, simultaneously occupying multiple positions and having multiple properties, a hazy cloud of potential, until we try to pinpoint its location. This concept of superposition, where a quantum system can exist in multiple states at once, is one of the most challenging ideas to wrap your head around because it contradicts our everyday experiences of a definite, predictable world. The key to understanding this isn't to try to force a classical analogy onto the quantum world, but rather to accept that reality at the smallest scales operates according to fundamentally different rules that we are still struggling to fully grasp. It's as though the universe is playing a trick on us, revealing that our intuitive understanding of cause and effect, of objects having definite properties independent of observation, simply doesn't apply at the quantum level. Now let's consider the implications of this experiment. If observation fundamentally alters reality, then what does that say about the role of the observer in the universe? Some interpretations of quantum mechanics, like the many worlds interpretation, propose that every quantum measurement causes the universe to split into multiple parallel universes, each representing a different possible outcome. This means that every time an electron goes through a slit, the universe branches into two realities, one where it went through the left slit and one where it went through the right slit, a truly mind-blowing concept. Others suggest that consciousness itself plays a crucial role in shaping reality, implying that our thoughts and perceptions are not just passively receiving information from the universe, but actively contributing to its form. Regardless of the ultimate interpretation, the double slit experiment serves as a profound reminder that our understanding of reality is incomplete and that the universe is far more mysterious and complex than we could ever have imagined. It is a humbling exercise, pushing us to confront the limits of our intuition and to embrace the unsettling possibility that the universe is, at its core, fundamentally strange and counterintuitive, prompting us to reconsider the very nature of existence itself. So, what do you think? Does the double slit experiment reveal a fundamental truth about the nature of reality, or is it simply a testament to the inherent weirdness of the quantum world? Let me know your thoughts in the comments below, and don't forget to like and subscribe for more explorations into the fascinating world of science and the universe around us. Bye, thanks for watching.